What is the meaning of distance when the nearest shore lies beyond imagination? Above the quiet earth, the night sky blooms with 1,000 light-silent fires adrift in a sea of darkness. Each one a sun, each one a furnace of creation, yet all scattered across a gulf so immense that even thought itself falters. And among them, hidden but constant, lies Proxima Centauri, the closest star beyond our own sun. It waits just over 4 light-years away, a span so slight upon the cosmic map, yet for humanity, it stretches like eternity. For years, for light itself to make the crossing light, the fastest traveler the universe has ever allowed. For human ships, bound by fragile engines and dwindling fuel, the journey is not measured in years, but in millennia. Here lies the paradox. Proxima is the nearest destination in the cosmic ocean, the first step beyond home. Yet it remains impossibly far, a beacon we can see but cannot touch. Its faint red glow whispers through the void as though calling to us across the dark. And so a question lingers. What awaits at that distant star? Around it, planets circle one, perhaps within the zone where liquid water might flow. A second cradle for life, or a barren rock lashed by flares of radiation. Proxima Centauri stands as both promise and reminder, a promise of another world, and a reminder of the vast solitude that binds us. Our closest neighbor is not a place we can reach, but a mystery we can only imagine, at least for now. The year was 1915, across the high plains of South Africa. The night sky burned brighter than it did in the smog-filled cities of Europe or the misty observatories of the Northern Hemisphere. It was here, at the Union Observatory in Johannesburg, that the silence of the universe yielded a new secret one that would forever change humanity's sense of cosmic proximity. Robert Innes, a Scottish-born astronomer working under the southern stars, was not a man chasing grandeur. His life had been spent in the quiet art of measurement, of cataloging stars, of tracing their paths across the firmament with patience and precision. At the time, astronomers were racing to chart the heavens, to refine the positions of known stars, and to test whether Newton's old clockwork sky could reveal deeper truths. Telescopes were still modest instruments by today's standards, but the revolution of photographic plates had begun. For the first time, the night could be captured not just by the eye, but by emulsion and silver, holding still what the heavens would never allow to rest. Innes' attention had long been drawn to Alpha Centauri, the bright double star blazing as the third most luminous object in the southern sky. It had been known since antiquity, yet its exact neighborhood remained a matter of curiosity. Alpha Centauri, A and B, danced together in a binary embrace, two suns locked in mutual orbit, luminous and golden. Astronomers knew these were among the nearest of the stellar family, but how near and whether any hidden companions lurked in the darkness remained questions unresolved. It was in pursuit of this question that Robert Innes discovered something unexpected. On photographic plates, he noticed a faint star, red and dim, creeping slowly across the background of fixed constellations. Its proper motion, its sideways drift against the celestial backdrop, matched that of Alpha Centauri, suggesting kinship, as if this small ember belonged to the same family. But its faintness was striking. If it truly belonged to the Alpha system, it would be smaller, cooler, and dimmer than its blazing companions, a star barely clinging to the threshold of nuclear fire. What he had uncovered was Proxima Centauri, the faintest, the smallest, and yet the closest star to Earth beyond the Sun. At first, its identity was uncertain. A red dwarf, catalogued and confirmed only in the years that followed. But the realization came swiftly. It lay closer to Earth than Alpha Centauri A and B, closer than Sirius, closer than any other light except the Sun, 4¼ light-years away. A number deceptively small in the grand geometry of the cosmos, yet unimaginably vast compared to any earthly journey. The early 20th century was a time of shifting paradigms. Humanity had only just begun to glimpse the larger universe. In 1915, the same year Einstein published his general theory of relativity, astronomers were still locked in debate about the scale of creation. Some argued that the Milky Way itself was the entirety of existence. Others suspected that spiral nebulae, barely visible through telescopes, were island universes, vast galaxies in their own right. Amid this uncertainty, the discovery of a new sun so near to us carried profound weight. It was as if the curtain of the night sky had been pulled back just a little farther, revealing that our cosmic neighborhood was stranger, denser, and more varied than once imagined. The instruments of Innes' era were fragile tools by modern reckoning. Astrometry, the precise measurement of star positions, was performed with painstaking rigor. Each photographic plate had to be exposed for long minutes, sometimes hours, the telescope fixed to track the slow spin of the Earth. The stars themselves etched faint lines of silver halide crystals onto glass. And then, with magnifiers and comparators, astronomers would measure shifts so slight they seemed beyond human perception. The faint wandering of Proxima across the background was not obvious to the naked eye, but to a patient observer with tools of precision, it was unmistakable. In this discovery, there was poetry hidden inside the mathematics. To recognize that the nearest star was not one of the great blazing beacons of the sky, not a Sirius or a Vega, but instead a modest ember, nearly invisible, without instrumentation, was to learn humility once more. The universe whispered its secrets not through grandeur, but through faintness, through the overlooked and easily forgotten. The astronomical community received the news with measured curiosity. The Union Observatory's announcement added a new entry to the growing catalogs of stars. Yet, behind the modest lines of a scientific report, there stirred something larger, a realization that the ladder to the stars had gained its first rung. Proxima Centauri, so faint, so near, stood as the true neighbor of the sun. Innes himself could not have foreseen how important this discovery would become. A century later, when astronomers turned their most sensitive instruments toward Proxima, they would find worlds orbiting at planets bathed in the dim crimson glow of a red dwarf. Worlds perhaps capable of oceans, atmospheres, and the chemistry of life. But in 1915, it was enough simply to know that such a star existed. The race to map the heavens was far from over. Within only a decade, Edwin Hubble would pierce the veil of the Milky Way and reveal the true scale of the cosmos, that the universe was not one galaxy, but billions. Against such immensity, the closeness of Proxima seemed almost trivial. Yet paradoxically, it became more important than ever. In a universe of staggering distances, this faint, dim red star stood as the first possible step outward to gaze upon it through the telescopes of the early 20th century was to strain against the limits of vision. It shone at 11th magnitude, barely brighter than the darkness itself. No one who looked upon it without knowledge of its identity would have guessed it to be special. And yet it was the closest ember beyond the sun, a symbol of both nearness and impossibility. The discovery of Proxima Centauri belongs to that class of revelations which alter not merely the map of the heavens, but the imagination of humankind. The stars ceased to be an undifferentiated sea of lights. They became neighbors, each with distances that could be measured, each with motions that could be traced, each with a story that could be told. For Robert Innes, the act of recognition was quiet, almost solitary, but for humanity, it was a moment of awakening. The first glimpse of a neighboring sun, a red dwarf hidden in plain sight, closer than any other, reminding us that the universe reveals its wonders, not through the obvious, but through the subtle. And with that subtlety came a question that has haunted every generation since. If the nearest star harbors mysteries unseen, how many more secrets wait in the endless darkness beyond? In the great tapestry of the night sky, most eyes are drawn to brilliance, the sharp glow of Sirius, the pale fire of Vega, the steadfast glimmer of Polaris. It is a natural bias of vision, for the human eye seeks what dazzles, what breaks the darkness with overwhelming clarity. Yet, the most common stars in the universe are not the great beacons, but the quiet embers. And Proxima Centauri, the nearest star beyond the sun, belongs to this hidden multitude. Probes a red dwarf. The name itself carries a note of humility. Red, the color of fading warmth, and dwarf, a word denoting smallness. Unlike the sun, which blazes at nearly 6,000 degrees Celsius on its surface, Proxima smolders at less than half that heat. Its light is not golden, but crimson so faint that even though it lies only for light years away, it cannot be seen without a telescope. To gaze at the southern sky unaided is to look straight past it, unknowing, blind to its presence. This dimness hides a paradox. For all their modest appearance, red dwarfs are the sovereign rulers of the cosmos. They make up the vast majority of stars in the Milky Way, perhaps 3/4 of the stellar population. They are the quiet citizens of the galaxy, countless and unremarked. Invisible to the naked eye, but shaping the structure of stellar evolution on a galactic scale. If the sun is a monarch among stars, red dwarfs are the multitudes. They do not reign through brilliance, but through persistence. Compared to the sun, Proxima Centauri is fragile in stature. Its mass is a fraction of our own stars, barely 12% of the sun's weight. Its radius would scarcely envelop Jupiter. And yet, within its tiny frame, the same alchemy of hydrogen fusion burns, though at a far slower pace. In the sun, hydrogen is consumed quickly enough to promise a lifespan of 10 billion years, half of which has already been spent. But in Proxima, the fuel is rationed with extraordinary thrift. A red dwarf may live for trillions of years longer than the universe has existed. No red dwarf has yet grown old. The cosmos itself is not ancient enough to have witnessed their deaths. In this contrast lies a revelation. The sun, bright and life-giving, is transient. It will exhaust its fuel and swell into a red giant, consuming its inner worlds before collapsing into a white dwarf cinder. Proxima, though small, will endure. It will burn patiently through epochs, so vast that the galaxies themselves may have shifted beyond recognition. If longevity is a form of strength, then it is the faint, overlooked stars, not the luminous giants, that carry the ultimate endurance. And yet, for all its nearness, Proxima eluded human recognition until the early 20th century. How could the closest star beyond the sun remain hidden for so long? The answer lies in the limits of perception. Human eyes evolved beneath the light of a Gi-type star, sensitive to the narrow spectrum of yellow and green where our sun shines brightest. The dim red glow of Proxima falls outside that favored range. It lingers at 11th magnitude, thousands of times dimmer than what the eye can perceive without aid. In the vast night sky, proximity does not always mean clarity. The closest neighbor can be the hardest to see. This truth extends beyond astronomy into philosophy. How many other mysteries lie unnoticed, not because they are distant, but because they are dim? The stars remind us that presence is not the same as visibility, that nearness does not guarantee understanding. Proxima's faintness carries other implications. For any planet orbiting it, the world would not bask in bright daylight, as Earth does. Instead, the skies would glow with a dull twilight, a permanent crimson wash, as though the sun never truly rose, but hovered at the edge of dusk. Shadows would be soft, horizons muted. Photosynthesis, if it arose, would not mirror Earth's greenery, but might rely on different pigments, adapted to drink in the deep red spectrum of the star's output. Life, if it exists there, would evolve under a very different sun, but there is danger in this faintness too. Proxima is not steady. Red dwarfs are notorious for their tempers. Where our sun produces solar flares that occasionally disturb satellites and communications, Proxima unleashes storms far more violent in proportion to its size. Its magnetic fields twist and snap, releasing torrents of radiation. Planets too close may be bathed in streams of charged particles, their atmospheres stripped away, their surfaces scorched by ultraviolet and X-rays. The paradox of red dwarfs is this: they live longer than any other stars, yet their fury may make them hostile to life. Still, astronomers marvel at the resilience of possibility. For every destructive flare, there are models suggesting worlds that might endure. A planet might shield itself with a magnetic field, much as Earth does. It might hide its oceans beneath ice or rock, sheltering life from the storm while still feeding on the star's warmth. In the vast time spans Proxima affords, life would have ages upon ages to adapt. Survival under such a star might be harsh. But persistence is not impossible. The shock of Proxima's nature is not merely scientific, but existential. Humanity has spent millennia looking upward, crafting myths and constellations from the brightest stars. The ancients gave names to Orion and Scorpius, to Sirius and Arcturus, to Aldebaran and Antares. Yet none gave a name to Proxima, though it is closer to us than all of them. It was invisible to their naked eyes, silent in their mythology. Its discovery required not the poetry of starlight, but the patience of instrumentation, the mathematics of motion, the precision of photographic plates. In this lies a lesson. The nearest truths may not be those revealed in brilliance, but those uncovered by quiet persistence. Red dwarfs like Proxima remind us that the universe is not built for human senses. It is built on scales of energy and endurance far beyond biological intuition. To live beneath the sun is to inhabit a world of golden warmth and rapid change. To live beneath Proxima would be to dwell under a dim ember, a star that barely flickers yet promises to endure for eternity. Which is the greater gift, the warmth of brightness or the patience of time? The answer may depend on perspective. In contemplating Proxima Centauri, the imagination stretches into paradox. Here is the closest star beyond the sun, yet invisible. Here is a sun so small that it barely registers against the void, yet so long-lived that it may outlast the galaxies themselves. Here is a star capable of nurturing planets yet prone to storms that might strip them bare. A neighbor so near that it feels within reach, yet so alien that it remains unfathomable. The humblest stars are the most enduring. The quietest suns are the most numerous. In Proxima Centauri, humanity encounters not just a neighbor, but a reminder. The universe is not built upon grandeur alone. It is built upon countless small flames burning patiently in the dark. Unseen yet eternal, and so the closest star is not a blazing beacon, but a whisper. Not a triumph of light, but an exercise in humility. It tells us that in the cosmic order, what matters is not only what dazzles, but what endures. Proxima Centauri burns on, not to be admired from Earth with naked eyes, but to be known through patient science. To be imagined through reflection, and perhaps, one day, to be touched by the vessels of a species that has always yearned for the stars. In the eternal cold of interstellar space, there exists a fragile zone of possibility, narrow band around each star, where conditions may permit the most precious of elements to endure in liquid. Form water, not locked in ice. Not scattered into vapor, but flowing freely across a surface. Carving rivers, filling oceans, feeding the chemistry that awakens life. Astronomers call it the habitable zone, but to the imagination it is more than a technical term. It is a threshold, a whisper of promise that amid the vast emptiness, some worlds may resemble our own. Around Proxima Centauri, this zone lies close and tight. The star burns faintly, its energy a fraction of the sun's, so its warmth barely reaches outward. A planet seeking liquid seas must huddle near, circling within a scant fraction of the Earth-Sun distance. Too far, and its oceans freeze into silence. Too near, and its surface bakes under relentless radiation. Somewhere in between lies the razor's edge where water might flow. Where a second Earth could exist. For decades this was speculation. A dream projected onto the faint red star that lingered so near yet remained unreachable. Then, in 2016, the dream shifted toward reality. The European Southern Observatory. Using the high-accuracy radial velocity planet, searcher HARPS announced the detection of a planet orbiting Proxima Centauri. Its name was Proxima. But the discovery was not made through the sight of telescopes capturing an image. For the planet is to faint, lost in the glare of its star. Instead, astronomers watched the star itself, searching for the tiny motions betrayed by gravity's pull. As a planet orbits, it tugs at its star, drawing it ever so slightly toward and away from Earth. The shift is invisible to the eye, but not to instruments of exquisite sensitivity. Through radial velocity measurements, Proxima's light revealed the faint wobble, a starlight signature of a hidden world. Proxima b was no giant like Jupiter, no barren ember like Mercury. Its mass was calculated to be at least 1.3 times that of Earth, placing it within the realm of rocky planets. And more than this, it resided squarely within the star's habitable zone. Not too close, not too far. A world where liquid water could, in principle, exist. The news spread like wildfire. Headlines leaped across the globe, proclaiming the discovery of a second Earth just beyond the reach of the sun. For the first time in history, humanity knew that a potentially habitable world orbited the very nearest star. The notion that our solar system might not be unique, that Earth's conditions might not be singular, gained a visceral symbol in Proxima b. It was no longer a matter of distant speculation about exoplanets around stars hundreds of light years away. It was a matter of our closest neighbor. Excitement was tempered with caution. Proximity did not mean certainty. The planet's orbit, so close to its star, raised challenges. It almost certainly experiences tidal locking, with one hemisphere forever facing the dim red sun and the other cloaked in perpetual night. Could an atmosphere endure under such extremes? Could oceans circulate warmth between day and night, softening the harsh divide? Could life, if it emerged, survive under the tempestuous flares of Proxima Centauri, which bombard the planet with radiation far more intense than Earth receives? These questions remain unanswered. No probe has touched its surface. No telescope has yet seen its oceans or skies. What exists is possibility, balanced precariously between hope and doubt. Yet possibility alone was enough to stir something deep within the human spirit. For thousands of years, humanity has gazed upward, wondering whether other Earths might exist. The ancients wove myths of twin worlds, of heavens populated with life like ours. Philosophers argued whether Earth was unique or merely one among countless realms. For generations, the question lingered unanswered. But with Proxima b, the debate shifted. The nearest star hosts a rocky planet in its habitable zone. The dream of the other Earth is no longer an abstraction. It has a name, a mass, an orbit, and a place in the sky. The implications stretch beyond science. To know that our nearest stellar neighbor may host a habitable planet reframes humanity's position in the cosmos. It suggests that Earth may not be the only cradle of oceans and skies. It offers a counterweight to the loneliness of the void. If life can exist there, then life may exist everywhere. And if life exists everywhere, then the universe is not a barren expanse of silence, but a living ocean of possibilities. Yet, the paradox remains. Proxima b is tantalizingly close, yet unreachable. For light years a distance so small on the scale of galaxies, yet so impossibly vast for human technology. With current spacecraft, the journey would take tens of thousands of years. To imagine standing on its surface, breathing its air, feeling its skies, is to stretch beyond the edge of what is possible today. The planet becomes a mirror of humanity's longing, near enough to see, far enough to deny. Still, the discovery of Proxima b has redefined the horizon. No longer is interstellar travel merely the dream of science fiction. Now it has a destination, a place that calls to us. Every plan for starships, every thought of solar sails, fusion drives, or laser-propelled craft finds its beacon in Proxima b. It is no longer a question of whether there is a world worth reaching. There is one waiting at the threshold of our cosmic neighborhood. And so the mystery of habitability deepens. What does it mean to call a planet habitable? Is it merely the right distance from its star, the right temperature for liquid water? Or is it something deeper, the presence of air, of chemistry, of resilience against a hostile sun? Proxima b embodies both the hope and the uncertainty. It is a reminder that habitability is not a guarantee, but a fragile interplay of conditions, a balance easily broken. Yet, perhaps the greatest significance lies not in the planet itself, but in the reflection it casts upon humanity. To dream of Proxima b is to dream of escape, of expansion, of continuity beyond Earth's fragile cradle. It is to imagine that we are not bound forever to this one world, but that there is another shore waiting across the dark sea in this way. The discovery of Proxima b is not merely a scientific achievement. It is a philosophical moment a turning of the human story. It whispers that the universe may hold many Earths, that our story may not end here, that the dream of another home is not fantasy, but a possibility written into the structure of the stars themselves. And so, the faint crimson light of Proxima Centauri now carries with it a shadow, a hidden world circling in silence. We do not yet know if it harbors oceans, continents, or air. We do not yet know if it shelters life, or if it is barren rock under an angry red sun. But we know it exists. And in that knowledge lies the seed of wonder, the spark of longing, the dream of the other Earth. At first glance, Proxima Centauri might seem humble, almost gentle. A dim red star, glowing faintly in the southern sky, too weak to be seen with human eyes. Compared to the golden blaze of the sun, it is small, subdued, a quiet ember smoldering at the edge of perception. And yet, beneath this outward modesty lies a hidden violence and unruly temper that shatters illusions of calm. Proxima Centauri is not a tranquil neighbor. It is a flare star, restless and volatile, capable of sudden outbursts that dwarf the quiet stability of our own sun. Stellar flares are among the most violent phenomena a star can unleash. They are born in the magnetic heart of a sun, where fields of invisible force twist, knot, and snap. On Earth's sun, such flares are inspiring but survivable bursts of radiation that may disrupt satellites and power grids, but rarely threaten the biosphere. On Proxima, the story is different. This red dwarf, though smaller and cooler than the sun, is proportionally far more explosive. Its compact size concentrates its magnetic fury. When its tangled fields rupture, they release torrents of energy that blast outward with extraordinary intensity, flooding space with ultraviolet light, X-rays, and showers of high-energy particles. Astronomers have witnessed these tempests with growing astonishment. In 2018, the Atacama Large Millimeter, Submillimeter Ray in Chile recorded a flare from Proxima Centauri so immense it brightened the star by a factor of 100 in mere seconds. For a few minutes, the faintest of suns became a violent beacon, flooding its planetary system with radiation. Other telescopes, including NASA's Chandra X-ray Observatory and Hubble, have observed similar events, eruptions that strike without warning, bathing any nearby worlds in a deadly brilliance. For planets like Proxima b, orbiting close within the star's habitable zone, such storms are not distant curiosities. They are existential threats. Where Earth circles the sun at a comfortable distance, shielded by a thick atmosphere and magnetic field, Proxima b orbits only a fraction of that distance from its star. It is forced into intimacy by necessity, huddling near to gather enough warmth from a dim red glow. But that closeness comes with a price. Each flare delivers radiation dozens, even hundreds of times stronger than anything Earth has endured. Over time, such bombardment may strip away atmospheres, erode protective ozone layers, and sterilize surfaces that might otherwise host life. The contradiction is haunting. The same star that offers the warmth for liquid water is also the architect of destruction. The cradle of habitability doubles as the hammer of ruin. In Proxima Centauri's light resides both the possibility of life and its undoing. Scientists have wrestled with this paradox. Some models suggest that a sufficiently strong magnetic field could shield a planet like Proxima b, deflecting the torrents of charged particles as Earth's field deflects the solar wind. Others propose that life, if it emerged there, might retreat beneath oceans or beneath rock, hiding from radiation as microbes do on Earth's ocean floors or in the cracks of Antarctic ice. In such refuges, biology might endure even amid cosmic tempests. The human imagination clings to this possibility, unwilling to surrender the dream of another Earth so near. And yet, the evidence is sobering. Observations from ultraviolet and X-ray monitoring suggest that Proxima's flares are not occasional, but frequent. Some occur daily. Each one chips away at planetary defenses. Over billions of years, even a thick atmosphere may be thinned to nothing, leaving a barren, airless world beneath an angry red sky. This duality transforms Proxima Centauri into a symbol of cosmic fragility. It is the reminder that habitability is not a gift, but a balance. Too much heat, too little protection, too much fury from a parent star, and the conditions for life vanish. Even in the nearest star system, where hope seemed brightest, the universe reveals its indifference. Yet there is a deeper reflection in this violence. The very stars that sustain life are not benevolent guardians, but indifferent furnaces of physics. They burn, they flare, they collapse, following laws of magnetism and fusion without thought or mercy. Life, wherever it arises, exists not because the universe is kind, but because life is stubborn. It carves out niches amid chaos, clings to moments of balance, persists despite the storms. On Earth, the story has always been one of resilience. Our planet has endured its own trials: asteroid strikes, volcanic winters, magnetic reversals, and solar flares. Each could have ended the fragile thread of biology. Yet life adapted, survived, and grew more complex. If life exists on Proxima b, it too would be a tale of survival against odds. Perhaps in the dim red twilight, hidden in oceans or beneath soil, something endures even now. Clinging to a precarious existence in defiance of stellar rage, the violence of Proxima Centauri forces humanity to confront a humbling truth. The search for other Earths is not simply a search for distance and orbit, but for stability. A planet may sit within the habitable zone and still be uninhabitable, stripped bare by the storms of its sun. Habitability is not geometry alone. It is the delicate interplay of star, planet, and time. And yet, even with this knowledge, the dream persists. The image of Proxima b lingers in the human imagination, not as a certainty of life, but as a question. Could habitability survive in the shadow of such violence? Could biology endure where physics seems determined to erase it? Or is Proxima Centauri a cosmic lesson, a reminder that not all hopes are realized, that proximity does not equal paradise? In the faint red glow of our nearest neighbor lies a contradiction that cuts to the heart of human longing. A star close enough to see, yet too hostile to touch. A world perhaps like Earth, yet battered by storms that may make it barren. The dream of another home collides with the reality of cosmic indifference, and so Proxima Centauri stands as both beacon and warning. It invites the imagination toward new worlds, while reminding us of the fragility of the conditions we take for granted on Earth. Oceans, atmospheres, stable suns, these are not universal gifts, but rare harmonies in a universe of turbulence in its flares. We see not only the violence of a red dwarf, but the precariousness of our own place in the cosmos. Life is fragile, habitability fleeting, and yet that very fragility makes the dream of survival, of discovery, and of reaching beyond all the more profound. The discovery of Proxima b in 2016 ignited a fire of imagination. For the first time, humanity knew of a potentially habitable world circling the nearest star. Yet, as with all great revelations, the finding raised more questions than it answered. Was this planet alone, a solitary wanderer in orbit around a dim red sun? Or was Proxima Centauri richer, a system of multiple worlds? Hidden in the star's faint light, waiting for the patient work of science to reveal them. The search deepened. Astronomers turned their instruments not just toward Proxima b, but to the faint whispers in the data that hinted at others. What emerged was a story both tantalizing and uncertain, a narrative that reveals how science is not the triumph of certainty, but the navigation of doubt. In 2020, evidence arose for a second planet, Proxima c, detected through the painstaking method of radial velocity. It was suggested to be a super-Earth, or perhaps a mini-Neptune, orbiting farther from the star, beyond the habitable zone. Unlike Proxima b, it was too distant and too cold for liquid water, likely a frozen world. Yet its discovery carried weight. If confirmed, it meant that Proxima was not just a star with one intriguing planet, but a small planetary system. The signals of Proxima c, however, came with ambiguity. Radial velocity relies on measuring the delicate shifts in a star's light as planets tug upon it. But the smaller the star, the more active and temperamental it becomes. Proxima's flares and magnetic storms complicate the data, creating noise that can masquerade as planets. Was Proxima C truly there, or was it an artifact of the star's turbulent surface? Astronomers debated, papers were written, and observations continued. The planet remained half-real, suspended between confirmation and illusion. Hints of yet another world emerged in 2020 to Proxima d. This one, if it exists, would be even closer to the star than Proxima b. Orbiting in just 5 days, at only a quarter of Earth's mass, it would be one of the smallest exoplanets ever detected. Its presence, inferred through the espresso spectrograph on the Very Large Telescope in Chile, again stirred fascination. A system of 3 worlds, each different, each caught in the dim gravity well of our nearest neighbor. And yet again, the signal was faint, perched at the edge of detectability, vulnerable to skepticism. Other instruments joined the search. The ALMA radio telescope in Chile once captured a strange emission near Proxima, a faint glimmer of radiation that some speculated might hint at dust, asteroids, or even planetary rings. For a brief moment, the imagination leapt toward images of a complex system, a miniature echo of our own solar family. But as analysis deepened, the signal faded into ambiguity. Dismissed by many as instrumental noise or background interference, such is the nature of exoplanet science. Discovery is never clean. Each planet is not revealed in shining clarity, but in trembling data, in lines of graphs, in signals that rise and fall against noise. It is a science of patience, of repetition, of cautious words, and uncertain conclusions. To announce a planet is to walk a narrow line between revelation and error. And so Proxima Centauri remains an enigma. It may host 1 planet or 3. It may harbor a complex system or only a solitary world orbiting in the dim glow of a turbulent sun. The truth is not yet settled. The instruments we wield, harps, espresso, calmar, among the finest humanity has built, capable of measuring starlight shifts of less than a meter per second. Yet even they strain against the limits when faced with the restless surface of a red dwarf. The signals are faint, the noise relentless, the certainty elusive. But in this uncertainty lies something profoundly human. Science is not the art of finding simple answers, but the practice of asking better questions. Each possible detection of Proxima C or D is not just a fact to be confirmed or denied, but a doorway into deeper inquiry. What if the system is richer than we know? What if small planets, unseen and uncounted, circle in the shadows, too faint for our instruments, but waiting for future eyes to find them? The uncertainty also mirrors the philosophical heart of exploration. Humanity seeks clarity, but the universe offers ambiguity. Every discovery comes wrapped in doubt. Every signal must be tested, every conclusion tempered with caution. The cosmos is not easily revealed. It resists the simple narrative, forcing those who seek it to dwell in patience. To live within mystery, still, even doubt carries power. The mere possibility of additional worlds around Proxima shifts our perspective. It suggests that planetary systems are not rare but common, that even the smallest and faintest of stars may host multiple companions. It whispers that the universe is not economical with its creations, but generous, scattering planets as freely as stars. For now, the truth remains hidden. Perhaps Proxima b is joined by siblings. Perhaps it circles alone. Perhaps Proxima d is real, a tiny world huddling close to its sun. Perhaps it is only an illusion written in starlight. The answer will come only with time, with more data, with sharper instruments, with the patience that astronomy demands. But in the meantime, the uncertainty itself becomes a lesson. To explore the universe is not to master it, but to be humbled by it. To know that even the nearest star system remains a mystery is to recognize how vast the unknown still is. We are surrounded not by answers, but by questions. And so, Proxima Centauri, so near and yet so elusive, continues to guard its secrets. A star barely visible, perhaps with worlds hidden in its light, perhaps not. Its system is a riddle, its truths tangled in noise, its revelations shadowed by doubt. And in that doubt, lies the essence of discovery itself, the recognition that the journey toward knowledge is never clean, never complete, always fragile, always unfinished. For in the end, the stars remind us that mystery is not the enemy of science, it is its companion. In every uncertain signal, every disputed detection, every fragile whisper of a hidden world is not a failure, but a step into the deeper silence of the cosmos, where truth awaits with infinite patience. Every star is a messenger. Every beam of light that reaches Earth is a story carried across the abyss, whispered from one corner of the cosmos to another. Proxima Centauri, though it is the closest star beyond the Sun, is no exception. Its dim glow arrives to us only after a long voyage for years. In 3 months through the black gulf of interstellar space, that light begins in violence. In the burning heart of a red dwarf, there, deep within the core, hydrogen atoms collide and fuse, releasing energy that struggles outward for centuries, scattering through dense plasma, bouncing between particles, until at last it emerges at the surface. Only then does it escape into the void, free to travel, unimpeded at nature's ultimate speed limit. Photons from Proxima journey at 300,000 kilometers per second, faster than any dream of human travel, faster than any technology could ever hope to reach. Yet even at that speed, the voyage takes more than 4 years. By the time the faint red glimmer enters the lenses of Earth's telescopes, Proxima itself has already changed. Its flares may have risen or subsided. Its planets may have rotated through countless orbits. Civilizations, if any exist there, would have spoken words already 4 years old before their light arrived. What we see is not Proxima as it is, but as it was. This is the paradox of astronomy. The farther one looks into space, the deeper one gazes into time. The Andromeda Galaxy shines at us from more than 2 million years in the past. Quasars, burning at the edge of the visible universe, reveal themselves only as they were billions of years ago, when galaxies were still forming. Even the nearest stars are memories, never the present. To look at Proxima Centauri is to look backward, to study a version of our neighbor that no longer exists. The human mind is accustomed to presence, to seeing what is before it. The chair, the tree, the face in the mirror. Yet astronomy defies this instinct. Telescopes are not instruments of the present. They are instruments of remembrance. The photons that strike their detectors are ancient travelers. To peer at Proxima through a telescope is to open a time capsule, to receive a message sealed years ago, arriving only now at the shores of Earth. Einstein's relativity deepens this truth. Time and space are not separate realms, but interwoven threads, and light is their messenger. The speed of light is not simply a velocity. It is the fabric's very limit. Nothing outruns it. To live under these laws is to live in a universe where contact is delayed, where presence is always past. If one could stand on Proxima b and gaze toward Earth, the view would not reveal the present world, but the Earth of 4 years earlier, its storms, its continents, its people as they were, not as they are. Every gaze across the void is a gaze into history. This reality reshapes the meaning of distance. For light years sounds small on the cosmic map, yet it is immense in human terms. Voyager 1, humanity's farthest probe, has traveled only 1/18,000th of the distance to Proxima in nearly half a century. The light that crosses that gap does so effortlessly. Human craft, by contrast, crawl by comparison. The star may be near in astronomical terms, but to us, it is a chasm. It's unreachable except through the messages of its light. The photons themselves are fragile things. Many will be scattered, absorbed, or lost before reaching Earth. Yet some endure. They enter the atmosphere, bending through layers of air, perhaps blurred by turbulence, before finally striking the mirrors of observatories. Their detectors convert them into data, traces of brightness against a sea of noise. In those traces lie revelations. The spectral fingerprints of Proxima's temperature, its flares, its chemical composition, the pull of planets tugging at its motion, all of it encoded in beams of light that began their journey long before they arrived. This is the strange. Intimacy astronomy creates. Humanity has never set foot on Proxima's worlds, has never sent a probe to skim its light. Yet it knows the stars, mass, its temperature, its fury, and its rhythms all gleaned from photons that survived the crossing. We know it not in presence, but in memory. And here lies a deeper reflection. To seek the universe is to embrace patience, to accept that truth arrives late, filtered through time. We never see reality as it is. We see echoes. We live surrounded by memory. Even the sun we bask in each day is already old. By the time its rays warm, our skin 8 minutes old. A delayed version of the furnace that sustains us. Every sunrise is already past. Every sunset is the last glimmer of light long departed. For Proxima, the delay is longer. To watch its faint glow is to watch the star for years gone. If one night it were to vanish, if fusion within its core somehow ceased, Earth would not know until years later. Its light would continue to arrive, faithful and unchanging, until the final photons completed their journey. Only then would the truth of its absence be revealed. Such is the nature of the universe. Presence is illusion. Time is woven into distance. The stars are not what they appear to be. They are what they were. And so, humanity peers into the night sky, not at the present cosmos, but at its memories. Each star is an echo, each galaxy a ghost. To study Proxima Centauri is to study a 4-year-old memory of our nearest neighbor, a reminder that even closeness in space does not erase distance in time. The star is near, but its presence is forever delayed, forever refracted through the lens of history. Yet perhaps there is beauty in this delay. To know that the universe we see is the universe as it was, is to realize that the night sky is a living archive, a record of the cosmos unfolding across billions of years. In those records lie stories of creation, of collapse, of endurance. Proxima's light is one such story, an intimate whisper from the nearest sun, carried patiently across the void to remind us that existence is never instantaneous, but always layered. Always remembered, the faint red photons arriving tonight left before the words of this narration were spoken. They began their journey when wars still raged, when discoveries had yet to be made, when the world was not yet as it is now. Tomorrow night, another wave will arrive, carrying with it another memory, another echo of what Proxima once was. Night after night, the star sends its messages across the silence, and night after night, Earth receives them. Piecing together the identity of a neighbor never seen as it truly is, Proxima Centauri stands as the closest star, yet it is forever distant in time. Its light teaches us that the universe does not give itself in presence, but in reflection. Humanity does not look outward and see the now. It looks outward and reads the past, and perhaps that is fitting. For in the end, all memory, all history, all understanding are acts of light crossing darkness. Arriving late, but still arriving, carrying truth not of the present, but of what has already been. Proxima Centauri is often imagined as solitary, a faint red ember glowing at the edge of the night. Yet it does not drift alone. It belongs tenuously to a greater family, the Alpha Centauri system. A trio of stars bound, perhaps precariously, by the invisible threads of gravity. Alpha Centauri A and B shine as a brilliant binary. Golden suns locked in an intricate dance, circling one another every 80 years. They blaze as lighthouses in the southern sky, steady and commanding. Proxima lingers on the outskirts, dim and almost invisible. A distant cousin clinging at the edge of the family's gravity well. It lies some 13,000 astronomical units away, more than 400 times farther than Neptune lies from the sun, from Proxima's skies. Alpha Centauri A and B would appear as dazzling twin beacons. Brighter than any star appears from Earth, but from Earth Proxima is barely perceptible, its bond to the pair hidden in faint motions and centuries of calculation. The question is not merely poetic, but scientific. Is Proxima Centauri truly bound to Alpha Centauri A and B? Or is it a wanderer, passing near them by chance, destined eventually to slip back into the solitude of interstellar space? Astronomers have long debated this question. The pull of gravity is subtle at such distances, and the motions of stars unfold across millennia. Measurements of Proxima's velocity suggest it is indeed gravitationally bound, orbiting the binary with a period that may span 500,000 years. But the margin of uncertainty is thin. A slight error in velocity, a faint tug from another passing star, could alter the conclusion. The fate of Proxima's companionship hangs on decimal places. If it is bound, Proxima's orbit is fragile and eccentric, stretched into vast ellipses that carry it through the peripheries of Alpha Centauri's domain. Over millions of years, such orbits are vulnerable. Passing stars, interstellar clouds, and the tidal forces of the galaxy itself can perturb them. A close encounter could loosen Proxima's hold, casting it adrift into the darkness, transforming it into a solitary wanderer once again. The fragility of this bond speaks to a deeper truth. Proximity is not always safety. To exist near greater masses is to live under constant influence, to have one's path shaped not by independence, but by gravitational negotiation. Proxima's history may have been sculpted by these tides. As it swung through its long orbit, the pull of Alpha Centauri, A and B, could have stirred its own system, disturbing the orbits of planets, altering comets, altering the architecture of its tiny domain. Perhaps worlds once circled closer, only to be cast outward. Perhaps icy bodies were perturbed inward. Delivering water or chaos to Proxima B, the neighborhood of stars is not serene, it is restless. And every orbit is a compromise. Such dynamics remind us that even the bonds of stars are impermanent. Stellar systems are not static constructs, but fragile alignments in a galaxy alive with motion. The Milky Way is a sea of gravitational encounters. Over cosmic time, stars approach, interact, and drift apart. Some pairs remain bound for billions of years. Others are disrupted and scattered. Proxima Centauri, so near to us and so central to our imagination, may itself be only a temporary member of a family destined to dissolve. For life, if any, exists on Proxima's worlds, this instability carries profound consequences. Planetary orbits depend on stellar stability. A shift in Proxima's long arc, a nudge from Alpha Centauri's gravity, could alter climates, disrupt atmospheres, or destabilize entire systems. Habitability is not only about the warmth of a star or the protection of an atmosphere, it is about the long-term serenity of cosmic architecture. A planet that enjoys liquid water today may be frozen or scorched tomorrow if its parent star is torn from its course. Yet, even in this fragility, there is perspective. The Earth itself is not immune to such instability. Over the history of the solar system, passing stars have brushed its outer edges, tugging at comets in the Oort cloud, sending icy visitors plunging inward. The sun, too, is not eternal in companionship. Billions of years from now, it will leave its local stellar neighborhood behind as the galaxy's tides carry it elsewhere. Proximity, in the cosmic sense, is always temporary. The Alpha Centauri system is a lesson in this truth. At its heart, two suns circle one another in gravitational embrace, steady yet ever-changing. At its periphery, Proxima lingers, faint, fragile, its bond uncertain. This is not the vision of stability humanity often craves in the stars. It is a vision of impermanence, of proximity as a source of tension rather than safety. To live near others is to be shaped by them, sometimes nurtured, sometimes threatened, always changed for astronomers. The uncertainty of Proxima's orbit is not a failure of knowledge, but a reflection of scale. Human lifetimes are too brief to watch the full sweep of its path. Instruments measure velocities, but nature withholds the last digits of precision. The question bound or free may not be answered for centuries. Yet in this uncertainty lies the very essence of astronomy, to live with doubt. To build understanding not on absolute knowledge, but on careful probabilities. Always provisional, always open to revision, and so, Proxima Centauri remains suspended in mystery. Perhaps it is a permanent companion to Alpha Centauri, A and B, circling them for billions of years to come. Perhaps it is a wanderer, temporarily caught, destined eventually to drift away into the void. Whichever is true, the reality is the same. Proximity is fragile. Stars, like planets and people, are shaped by their neighbors. The closeness that invites connection also invites chaos. The emotional weight of this truth is profound. Humanity often looks to Proxima as a symbol of possibility, the nearest sun, the beacon of another Earth. Yet proximity is no guarantee of safety. It is a relationship fraught with tension, where gravity binds and threatens in the same breath. To dream of Proxima is to dream of a neighbor whose closeness is double-edged, offering the warmth of connection, yet carrying the seeds of disruption in this. The star becomes a metaphor not just for cosmic systems, but for existence itself. Safety is not found in nearness alone. Order is not guaranteed by proximity. The universe reminds us that even the closest bonds are delicate, and that stability is not a promise, but a fleeting condition carved from the chaos of motion. Proxima Centauri's light reaches us across 4 years of distance. Its planets circle in fragile orbits. Its path around Alpha Centauri A and B stretches across hundreds of thousands of years. At every level, it is a study in instability, in the delicate balance of forces too vast to master. And yet, in that balance it endures. Faint, precarious, unpredictable. Still it endures. And so, Proxima Centauri teaches a final paradox. Closeness is not certainty. Proximity is not peace. Even the nearest neighbor may carry threats unseen. To dwell near is to live under influence, to navigate the fragile line between harmony and chaos. The faint red star at the edge of Alpha Centauri's family is not simply a symbol of possibility, but a reminder of the instability that shadows all creation. The human eye has never seen Proxima Centauri as it truly is. It is too faint, too distant, too elusive for naked sight. And yet, over the past century, humanity has built instruments to stretch vision beyond its limits, machines of glass, metal, and mathematics that catch whispers of light and transform them into knowledge. Through them, the faint red star has been drawn into focus. Its storms mapped, its planets suspected, its possibilities imagined. The Hubble Space Telescope, orbiting high above Earth's atmosphere, has traced Proxima's flares in ultraviolet light, revealing eruptions far more violent than once believed. It has measured the subtle changes in brightness that betray the restless nature of a red dwarf. Chandra, the X-ray observatory, has captured the high-energy storms unleashed by Proxima's magnetic field's flares that surge with deadly radiation, lighting its planets in invisible searing brilliance. These are not gentle portraits, but stark revelations of a star that both warms and wounds its worlds. From the ground, other instruments have joined the effort. The Atacama Large Millimeter Submillimeter Array, ALMA, perched in the thin air of Chile's desert plateau, has recorded the faint radio whispers of dust around Proxima, possible remnants of comets or asteroids stirred by its gravity. Gaia, the European mission mapping the precise motions of billions of stars, has pinned down Proxima's position with unprecedented accuracy, charting its slow drift through the galaxy and refining our understanding of its long, fragile orbit around Alpha Centauri. And then came the James Webb Space Telescope. With its golden mirrors unfolding into the cold silence beyond the moon, Webb turned its gaze toward exoplanets with tools designed to detect the faintest traces of atmospheres. Its instruments dissect starlight as it filters through alien skies, searching for water vapor, carbon dioxide, methanea, molecular fingerprints of habitability, even the tantalizing signs of life. For Proxima b, the challenge is immense. A planet too small, too dim, too near a turbulent star, seen from too far away. Yet Webb represents the pinnacle of human capacity. An eye sharp enough to glimpse what once seemed impossible. Parallel to these telescopes, another project listens in silence. Breakthrough Listen, a search for technosignatures, has pointed radio dishes toward Proxima, scanning for transmissions that might betray intelligence. Its goal is not to map planets, but to eavesdrop on possibility, to test whether the nearest star carries not just worlds, but voices. So far, the sky has been quiet. A few anomalous signals have flickered through the data, but all have dissolved under scrutiny into earthly interference. Still, the effort continues, for the silence of space may itself be a message. And the act of listening is as profound as the hope of hearing. Despite these tools, the distance remains merciless. For light years a gulf that no telescope can cross. Instruments can dissect light, measure wobble, model atmospheres, but they cannot walk the surfaces of Proxima's planets. They cannot feel their air or touch their seas. Even the finest spectrographs, like harps and espresso, can only infer. A slight tug on a star's spectrum becomes a planet. A faint dip in brightness becomes a world. Knowledge is built on echoes, probabilities, interpretations of signals caught at the edge of certainty. And here the question deepens. Can we truly know a world without visiting it? Science thrives on data, on measurement, on inference. But planets are more than orbits and masses. They are landscapes, climates, histories. To know Earth, one must stand beneath its skies, hear its storms, feel its oceans. To know Proxima b or any of its suspected siblings requires a journey science has not yet achieved. For now, humanity peers from afar, piecing together fragments of truth from a distance that will not shrink in a human lifetime. This tension lies at the heart of exoplanet science. The hunger of discovery collides with the limits of distance. Each new tool sharpens vision, yet each also reminds us how faint and fragile the signals are. The line between discovery and doubt remains thin. Proxima b may have an atmosphere, or it may be stripped bare. It may have oceans, or it may be frozen wasteland. Its sky may glow red with a perpetual dawn, or it may be an airless void beneath a silent star. We do not yet know, and perhaps we cannot know, not fully, not without presence. Yet even in this uncertainty, the act of searching carries meaning. Every photon caught by Hubble, every flare mapped by Chandra, every spectrum traced by Webb is not just data disconnection. It is humanity stretching itself across 4 light years, refusing to accept the boundaries of the eye, refusing to surrender to ignorance. To peer into Proxima is to affirm the human instinct to reach outward, even when the reaching cannot yet touch. And so the nearest star becomes a mirror of the human condition. It is close enough to stir hope, but distant enough to remain untouchable. Science presses against this boundary, deploying its finest instruments, listening with its most sensitive ears, gazing with its sharpest eyes. Still, the answers arrive in fragments, incomplete, provisional. Proxima remains, above all, a reminder of limits. But perhaps the limits themselves carry meaning. To yearn for answers that cannot yet be grasped is to inhabit the very essence of curiosity. To hunger for knowledge despite distance is to be human. The universe reveals itself slowly, cautiously, always withholding as much as it grants. And in that withholding lies the beauty of the pursuit. Proxima Centauri is a neighbor seen through a veil of light years. Its worlds may be habitable or barren. Its skies may cradle life or silence. Science has sharpened its tools, deployed its telescopes, refined its models, but the truth remains suspended beyond reach. Yet in the very act of looking, of listening, of stretching perception to its edge, humanity finds itself reflected, not as a species of answers, but as a species of questions. The hunger of science meets the limits of distance. And still, the search goes on. Across the silence of interstellar space, Proxima Centauri glimmers as the nearest destination, for light years. On the map of the cosmos, it is nothing a step across the threshold of our galaxy, a breath against eternity. Yet for humanity, it is impossibly far. With today's spacecraft, the journey would take tens of thousands of years, longer than all of recorded history. Proxima stands as both neighbor and exile, close enough to tempt the imagination, distant enough to deny it, and so the dream emerges, to close the gulf, to reach across for years of light and arrive within a single human lifetime. The dream has taken many forms: fusion drives, antimatter engines, generation ships wandering for centuries, but none have yet leapt from speculation into reality. Until, in the early 21st century, a new proposal captured attention. Breakthrough Starshot, its vision was audacious. Instead of building vast starships to carry generations, it sought to send tiny probes, no larger than a hand, sailing on beams of light. Each probe would be attached to a wafer-thin sail, a membrane of reflective material spanning only a few meters. On Earth, an array of powerful lasers would fire upward, focusing their energy on the sail, driving it forward with unimaginable acceleration. At near one-fifth the speed of light, these fragile craft could cross the distance to Proxima in just over 20 years. Not centuries. Not millennia. Decades. The concept was as elegant as it was daunting. A fleet of light sails, each carrying miniature cameras, sensors, and transmitters, would be pushed into interstellar space at speeds no human craft had ever approached. On arrival, they would fly past Proxima and its planets, snapping images, measuring atmospheres, searching for signs of habitability. Then, with tiny transmitters, they would beam their discoveries back across 4 years of darkness to Earth. For the first time, humanity would not simply observe Proxima's worlds from afar, but receive direct messages from their skies. But between dream and reality stand the boundaries of physics. To propel such sails requires lasers of unprecedented power, capable of focusing tens of gigawatts on a target millions of kilometers away. The engineering challenge is staggering. The sail must endure acceleration forces thousands of times greater than gravity. It must survive dust and gas in interstellar space, collisions at relativistic speeds that could shatter it in an instant. Its instruments must be microscopic, yet resilient. Its communication powerful enough to send a signal home across light years, with only milliwatts of power. Every aspect of the journey teeters on the edge of impossibility, and yet it is precisely this impossibility that fuels the dream. To propose Breakthrough Starshot was not to claim certainty, but to open a horizon. It was to remind humanity that the path to the stars is not barred by imagination, only by patience and physics. With each advance in material science, in optics, in computation, the dream inches closer to possibility. The tension is profound. On one side lies the hunger for exploration, the ancient desire to cross oceans and climb mountains, transposed now onto a cosmic scale. On the other lies the stubborn wall of distance, the unyielding fact that the stars are far and the universe grants no shortcuts. Dreams of exploration collide with the boundaries of physics. Yet, in that collision, courage is born. For interstellar travel is not simply a technical ambition. It is a philosophical act. To build light sails aimed at Proxima is to declare that humanity's story is not bound to one world, nor to one star. It is to say that curiosity is stronger than impossibility, that yearning is more enduring than limitation. Even if no probe sails in this century, the idea itself alters the trajectory of thought. It seeds generations with the vision of a reachable neighbor, with the conviction that impossibility is only temporary. Other concepts join the chorus of speculation. Some imagine fusion engines harnessing the same fire that fuels the stars. Others propose antimatter drives, where particles and antiparticles annihilate to release energy 1,000 times more powerful than nuclear reactions. Still others envision vast generation ships, carrying entire populations who live and die during a voyage spanning centuries. Each is a dream deferred by technology, yet each affirms the same truth. Humanity refuses to accept immobility. What makes Proxima different is its proximity. Other stars may remain forever abstract, but Proxima tempts with nearness. It whispers, "I am the first step." To imagine a journey to its worlds is to take the dream of exploration from myth into plausibility. A star that once seemed unreachable becomes a target, a goal, a destination marked by physics rather than fantasy. And so, telescopes continue to watch, and scientists continue to plan. The challenges are immense, the timeline's long, but the dream persists. For to abandon it would be to surrender something essential, the belief that humanity's story is not finished on Earth, or even under the sun, but will one day extend outward into the larger sea. Perhaps no probe will sail within our lifetime. Perhaps the engineering will prove too great, the funding too scarce, the patience too thin. Yet the dream itself carries weight. It is the courage to imagine despite impossibility. It is the refusal to let distance dictate destiny. The faint light of Proxima Centauri, arriving 4 years late to Earth, stirs this vision. It is not merely a star, not merely a neighbor. It is a challenge written into the sky. To see it is to confront the boundary of what is possible, and to choose whether to yield or to dream. And so, humanity stands at the threshold of interstellar imagination. The sails have not yet been built, the lasers not yet fired, the probes not yet launched, but the dream has already departed. It sails not through space, but through time. Carried by thought and ambition, destined perhaps to outlast those who first imagined it. Proxima Centauri waits, patient as all stars are patient. Whether visited in decades, centuries, or not at all, it will endure. But the dream of reaching it, the courage to envision the impossible, is a light that already travels across the void. A light born not of stars, but of human will. It is tempting to imagine the universe in the image of the sun. Golden light, steady warmth, a star whose brilliance sustains life and lends clarity to the skies. For centuries, humanity has looked upward and assumed that the sun must be ordinary, that its kind must be the template of creation. But the truth, revealed through careful surveys of the galaxy, is otherwise. The sun is not common. It is not typical. It is an exception. The most numerous stars in the Milky Way are not blazing giants, nor sun-like twins, but quiet embers. Red dwarfs. Small, faint, unremarkable to the naked eye. They make up nearly 3/4 of all stars, scattered like dust through the spiral arms of the galaxy. Where the human eye seeks brightness, the galaxy offers subtlety. Its true architecture is built not on grandeur, but on countless invisible points, glowing too dim to notice without the aid of telescopes. And here lies a cosmic irony. The nearest star to the sun is not a sibling of familiar brightness, but one of these quiet multitudes, Proxima Centauri. Our closest neighbor is not a twin, but a representative of what is most ordinary in the galaxy. The faintest of stars, yet the most common. In its crimson glow lies the truth of our surroundings. The universe is not lit by suns, but by Proximas. This realization reshapes the search for life. If planets can orbit red dwarfs, then the potential cradles of biology multiply beyond counting. For every star like the sun, there are dozens of Proximas, each with the possibility of worlds in tight orbits. Each with habitable zones nestled close to the warmth of a dim ember. In the Milky Way alone, there may be tens of billions of such planets. Each one, a stage upon which life might emerge. But the promise is shadowed by challenge. Red dwarfs are violent in youth, their flares scouring nearby planets with radiation. Their habitable zones lie close to the star. So close that worlds are likely tidally locked, one side scorched in eternal day, the other frozen in endless night. The delicate balance of habitability becomes precarious. Life may endure, or it may be driven underground, surviving only in oceans or beneath rock, hidden from the fury above. This duality, commonness and hostility, defines the paradox of red dwarfs. They are abundant, enduring for trillions of years, long after brighter stars have faded. Yet they are tempestuous, their planets caught in precarious conditions. If life is resilient, if it can adapt to darkness and radiation, then the galaxy may be teeming with biology around these stars. If not, then their abundance is a cruel mirage. Billions of barren systems whispering only of potential never fulfilled. Proxima Centauri embodies this paradox. It is the nearest example, the test case written on the sky. In its faint light lies both hope and doubt. It reminds humanity that the search for another Earth will not likely find a sun-like twin, but a world orbiting a red dwarf. The other Earth, if it exists, will not bask in golden daylight, but in crimson twilight. Its seas will not sparkle under a bright sky, but glimmer faintly beneath a dim, red sun. Its life, if it breathes, will breathe under conditions alien to Earth's, shaped by a star far smaller and stranger than the sun. And yet, perhaps this is the greater lesson. Humanity's search for normality in the cosmos must confront what is truly normal, not what is familiar. The universe does not conform to human expectations. It offers not what the eye desires, but what it has built in countless repetition. Proxima is not the outlier, it is the rule. The sun is the anomaly. The neighbor star, faint and overlooked, is the truer mirror of the galaxy's nature. In this realization lies a humbling perspective. The human story, shaped under the light of an uncommon star, is an exception. A rare note in a symphony dominated by quieter tones. To search for life elsewhere is to ask whether that symphony carries melody in the faint embers as well as in the golden fires. Proxima, in its proximity, demands that this question be faced not as speculation, but as reality. Astronomers now frame their surveys accordingly. Missions, such as Kepler and TESS, scanning the galaxy for exoplanets, find their greatest harvest around red dwarfs. The signals are easier to detect. Small stars wobble more strongly under the tug of orbiting planets, and the dips in brightness caused by transits are more pronounced. The census grows rapidly, thousands of planets found, many orbiting stars not unlike Proxima, dim and long-lived. If the galaxy holds life, it is most likely to be under red light, not yellow. And so the irony sharpens. Humanity, nurtured under an uncommon sun, seeks life by projecting its own conditions outward. Oceans, skies of familiar warmth. Yet the greater likelihood is that if life thrives elsewhere, it does so in alien forms shaped by faint crimson suns. Evolved in rhythms foreign to Earth, the dream of another Earth may not be the dream of another sun, but of another Proxima. What Proxima Centauri reveals is not just the possibility of neighbors, but the reality of cosmic normality. It tells us that the universe is not built in our image. It tells us that to understand the galaxy, we must let go of the assumption that Earth's conditions are universal. To embrace the true commonness of red dwarfs is to embrace the possibility that life itself may be stranger than we imagine. More resilient, more diverse, more alien. And yet, in this strangeness lies comfort. For if life can exist under red dwarfs, it may exist almost everywhere. The galaxy becomes not a desert, but an ocean, its waters tinted red, its shores unfamiliar, but its vastness alive with possibility. Proxima, in its dimness, becomes a symbol of abundance. A reminder that the ordinary, multiplied across billions, becomes extraordinary. Our nearest neighbor is not a twin of the sun, but a representative of the galaxy's true children. In its faint light, humanity sees not a mirror of itself, but the pattern of creation repeated across the Milky Way, Proxima Centauri. Quiet and unremarkable is the face of the cosmos, as it is not as we wish it to be, but as it has always been, and in that realization lies a deeper humility. To search for life is not to search for ourselves, but to search for what is universal. To gaze at Proxima is to see the ordinary star, the one that defines the galaxy, the one that tells us that in the vast silence, what is near and dim may also be what is most common, most enduring, most true. Proxima Centauri burns faintly, a small ember in the cosmic night. Its light is weak, its heat meager, and its violence unpredictable. Yet even here, amid flares and dimness, astronomers ask the question that refuses to die. Could life exist? And if so, what shape would it take beneath such a sky? To imagine life under a red dwarf is to imagine a world unlike Earth. In the habitable zone, a planet orbits close, so close that the tidal forces of its star almost certainly lock its rotation. One hemisphere stares eternally into the red sun, scorched in a permanent dawn, while the other is plunged into endless night. Only the twilight ring between them, the terminator, might offer balance. Here, in the perpetual glow of a crimson horizon, water might flow, winds might circulate, and life might cling. It would be a world without day or night, but with an eternal in-between. A landscape forever caught in transition. What forms could biology take under such conditions? On Earth, life is sculpted by cycles, sunrise and sunset. Seasons of warmth and cold, the rhythm of day and night that shapes every living thing. But under Proxima's light, there is no cycle, only constancy. Plants, if they arose, would not follow the rhythms of photosynthesis, as on Earth. Their pigments would not be green, tuned to sunlight, but dark, perhaps black or deep crimson, adapted to drink in the faint, narrow glow of a red star. Photosynthesis itself might evolve differently, optimized for wavelengths the human eye cannot see. Two creatures born there, a dim red sky would not be strange, it would be normal. But Proxima is not gentle. Its flares unleash torrents of radiation, bathing its planets in bursts of ultraviolet and X-rays. If life exists, it must endure this chaos. Some speculate that organisms could evolve protective pigments, shielding themselves with natural sunscreens. Others imagine biology retreating below the surface, thriving in oceans, under ice, or within rock. Shielded from radiation by layers of water or soil, microbes on Earth already survive such extremes hidden in the Antarctic ice. Within deep caves or around hydrothermal vents on the ocean floor, if Earth's life can endure radiation and darkness, why not life beneath a red dwarf's temperamental light? Perhaps alien eyes, if they exist, would perceive the flares not as disaster, but as whether a natural cycle endured, as storms are endured on Earth. A burst of radiation might trigger dormancy. A flare might drive chemical cycles that feed ecosystems, bursts of energy punctuating the long quiet of twilight. Where humans see destruction, alien biology might see rhythm. Speculation deepens further when seen through the lens of quantum possibility. For life is not only a matter of biology, but of perception. What does it mean for a species to call a world normal? For humanity, the golden light of the sun, the blue sky scattered by an atmosphere, the rhythms of day and night, these define reality. But to a creature born under Proxima, normality would be a dim red glow, sky lit always by dusk, a land where shadows never move. The flare of ultraviolet light might be the only daybreak they ever know, a sudden surge of brightness, seen not as threat but as awakening. Their concept of time, of life, of rhythm itself, would be alien. This raises the deeper philosophical question: is life fragile or infinitely adaptable? On Earth, it often appears fragile. Ecosystems collapse under small changes, species vanish with shifts in climate. Yet beneath this fragility lies resilience. Life has survived mass extinctions, asteroid impacts, volcanic winters, global ice ages. It adapts, finding niches in boiling springs, in radioactive waste, in the crushing depths of oceans. If life is defined not by comfort but by persistence, then perhaps it is less fragile than it seems. Perhaps the universe is alive, not because stars are kind, but because life is stubborn. Under red dwarfs, that stubbornness would be tested. The challenges are immense. Tidal locking, radiation, violent flares, meager warmth. And yet, given billions of years far longer than Earth has had, life might not only adapt, but flourish. Entire ecosystems could evolve beneath the glow of crimson stars, unseen but enduring. Enduring as normal to themselves as Earth's brilliance is to humanity. The speculation is not idle fantasy. It informs science. Astronomers searching for biosignatures must ask not what life looks like on Earth, but what it might look like elsewhere. Oxygen, methane, carbon dioxide, these are the gases that betray biology here. But alien metabolisms under red dwarfs might leave different traces. To search only for Earth-like markers is to risk blindness. To expand imagination is to expand detection, and so imagination itself becomes a tool of survival. It allows humanity to peer into conditions it has never known, to anticipate forms of life it has never seen. To speculate about life under Proxima is to train the mind to accept the alien, to embrace the unfamiliar as possible. Without imagination, the search for life would be narrow, confined, blinded by expectation. With imagination, it opens into the vast diversity the cosmos may hold. In this way, Proxima Centauri is not only an object of study, but a frontier of thought. It forces reflection on what life is, what life requires, what life can endure. It asks whether biology is fragile, tied to narrow conditions, or whether it is universal, endlessly adaptable, capable of thriving in skies of red, in seas of twilight, in worlds forever alien. The truth is not yet known. Proxima's planets remain unseen, their atmospheres unmeasured, their surfaces imagined but not confirmed. Yet in the silence, in the uncertainty, the mind reaches outward. It paints pictures of twilight landscapes, of dark forests drinking red light, of oceans glowing beneath eternal dusk. It imagines creatures whose rhythms are not Earth's, Proxima's creatures who see their world as normal, their star as home, their life as inevitable, and perhaps that is the deepest lesson. Life may not require Earth-like conditions to arise. It may not require golden suns or blue skies. It may require only the will to persist, the chemistry to adapt, the patience to endure. Fragile in the short term, infinitely adaptable in the long, Proxima Centauri, in all its dimness and fury, becomes the stage for this speculation. It is not only a star, not only a neighbor, but a mirror of possibility. In its faint glow, humanity sees not only a question of habitability, but a question of itself. Are we fragile, bound to narrow conditions? Or are we adaptable, capable of surviving under alien suns? The answer lies not only in science, but in imagination. And so, imagination becomes more than fantasy. It becomes preparation. It becomes survival. To imagine life under Proxima's red glow is to stretch the definition of life itself. To prepare for the discovery that when the universe finally answers the question of whether we are alone, the answer may be stranger and more wondrous than we ever believed. To measure the universe is to measure not only space, but time. When Albert Einstein unveiled the theory of relativity in 1915, the cosmos shifted from a stage upon which events unfolded into a fabric where space and time were woven together. No longer could distance be measured simply in kilometers, nor time in seconds. Together they formed space-time, a continuum shaped by mass, curved by energy, and bounded by the unbreakable law that nothing outruns light. It is this law that makes Proxima Centauri both near and impossibly far. For light years, a number that seems small against the width of the galaxy, but absolute in its resistance to human ambition. Light moving at 300,000 kilometers per second crosses the gulf in just over 4 years. A spacecraft, bound by the limits of propulsion, would take tens of thousands. Relativity does not merely describe this distance, it enforces it. The paradox deepens with imagination. In relativity, time itself bends. A ship approaching the speed of light would experience time more slowly than observers on Earth. To its crew, the journey to Proxima might take years, while centuries could pass at home. Distance contracts for the traveler, but expands for those left behind. The universe, through Einstein's equations, offers a strange compromise. Proximity can be gained at the cost of separation from the present. The dream of reaching the stars becomes entwined with the dream of leaving time itself, and yet, for satellite travel, the great fantasy of science fiction remains forbidden. To exceed light is to violate the structure of causality, to unravel the order of cause and effect. Relativity insists that information cannot move faster than photons, that no signal can overtake the very fabric of space-time. Proxima, so near in the imagination, is held behind this wall of physics. A neighbor forever delayed. Still the yearning for shortcuts persists. Humanity's mind has always reached toward the impossible. Theoretical physics has offered glimpses of pathways, speculative and fragile. Wormholes, tunnels through space-time, shortcuts between distant regions, predicted by solutions to Einstein's equations. If such passages exist, they might fold the distance between stars, making Proxima only a step away. But wormholes, if real, would require exotic matter to remain open. Negative energy densities that may not exist in the fabric of reality, they remain equations on paper, whispers of possibility never touched. Then, there is the Alcubierre drive, a speculative idea born in the 1990s. Instead of moving a ship faster than light, it would move space-time itself. A bubble of warped geometry, contracting space ahead expanding space behind, carrying a vessel like a surfer on a cosmic wave. Within the bubble, the ship would not exceed light speed. Yet from the outside, it would appear to cross interstellar distances in moments. The mathematics holds, but the physics resists. The energy required is vast greater than the mass of entire stars, negative in sign, demanding a substance never observed. Like wormholes, it remains a dream. A sketch at the edge of science where imagination outpaces reality, and yet to contemplate these ideas is not wasted effort. For they reveal the boundaries of knowledge, the edge where physics confronts mystery. They remind us that the laws which bar us from Proxima also protect the coherence of the universe. Without relativity's limits, cause and effect would collapse, and the cosmos itself might unravel. The speed of light is not a prison, but a pillar. It preserves the order by which galaxies form, stars burn, and life endures. Proxima Centauri then becomes a symbol of this paradox. It is close enough to tempt, distant enough to resist. Its light takes only 4 years to arrive, yet its worlds may remain untouched for millennia. It represents the promise of the reachable and the barrier of the unreachable, bound together by Einstein's equations. The emotional weight of this truth is heavy. Humanity is a species of voyagers, born to cross frontiers. Oceans, mountains, skies all have yielded to curiosity. But the stars resist. Relativity whispers that no matter how strong the engines, no matter how vast the sails, the speed of light is the horizon. Beyond it, the dream collapses. And yet, to stop dreaming is unthinkable. Perhaps then, significance of relativity is not only in its restrictions, but in the courage it demands. To dream of wormholes, of warp drives, of shortcuts through space-time, is to admit the impossibility and reach anyway. The yearning itself becomes an act of defiance, a declaration that imagination will not be bound. Even if physics decrees otherwise, in this tension lies the essence of the human story. The stars remind us of limits, and we answer with longing. Proxima Centauri is more than a neighbor. It is a symbol of the boundary between what is known and what is dreamed. To measure its distance is to measure the distance between science and imagination, between reality and desire. And so, Proxima teaches through absence. It is near, but unreachable. Its worlds are suspected, but unseen. Its light arrives, but its presence remains withheld. It embodies relativity itself, a reminder that space and time are inseparable. That distance is never only distance, but also delay, memory, history. To reach it requires not only engines, but new ways of thinking, new physics not yet born. Until then, humanity watches. Telescopes gather photons, spectrographs sift signals, theories bend equations. The dream of faster-than-light travel lingers as myth in mathematics, a yearning for shortcuts through the impossible. And in that yearning lies the deepest reflection. The universe is vast, not to deny life, but to give it something to reach toward. Proxima Centauri glows faintly in the southern sky. 4 years away, yet separated by the wall of light. Einstein's relativity guards it, protects it, and denies it all at once. The star waits patient, while humanity confronts the paradox of its own ambition. To dream of Proxima is to dream of breaking the horizon of light. To accept Proxima is to accept that yearning itself may be the greatest voyage of all. The faint glow of Proxima Centauri has never been visible to the naked eye. For millennia, no ancient storyteller traced its position across the heavens. No myth named it. No culture placed it among the constellations. It passed in silence, unseen, a neighbor hidden in darkness. And yet, in the span of just a century, it has become something more. Though still invisible, it now burns brightly in the imagination. Proxima Centauri, the nearest star beyond the sun, has emerged as a canvas upon which humanity projects its oldest longing. The dream of other worlds, science revealed its existence. Literature gave it meaning. Once astronomers announced its proximity, storytellers claimed it as a destination. Proxima became a stage for narratives of migration, of exile, of exploration. In novels and films, it has appeared as the first shore humanity might reach beyond the solar system. The site of colonies, of alien encounters, of survival after Earth has faltered. Its planets, discovered only in recent years, were anticipated long before by the voices of fiction. Writers did not wait for data. They filled the silence with imagination, populating its faint light with oceans, continents, civilizations. In this way, Proxima is more than a star. It is a mirror for the human condition. Its nearness makes it unique. Close enough to stir the possibility of travel, far enough to deny it. And so it becomes the perfect stage for human reflection. To dream of Proxima is to dream of escape, of continuity, of belonging in a universe that often feels indifferent. To imagine walking beneath its skies is to imagine an answer to loneliness, the loneliness of being confined to one world. One sun, one fragile biosphere. Science fiction has long recognized this. From early pulps to modern cinema, Proxima has appeared again and again as the symbol of the reachable frontier. Not impossibly distant, like the galaxies, but close, a tangible destination where human ships might plausibly arrive. In its crimson glow, artists have found both hope and warning. Hope that humanity might endure beyond Earth, and warning that the stars are not gentle, that survival elsewhere will not come without struggle. But Proxima's meaning extends beyond fiction. It also speaks to the cultural imagination in subtler ways. Paintings, films, and speculative art often depict it as a second sun. Dim but steady, casting alien landscapes in perpetual dusk. Music has invoked its name, weaving its light into metaphors of distance and longing. Even in philosophy, Proxima has become shorthand for the tension between nearness and impossibility, a star that embodies both hope and humility. This cultural resonance reveals something profound about the relationship between science and story. Astronomy provides the facts: distance, mass, orbit, spectrum. But story provides the meaning. Data tells us that Proxima is 4 light-years away. Imagination tells us what that distance feels like. Science shows us that planets circle it. Fiction explores what it would mean to walk on them. Between the two, Proxima becomes both a real star and a symbol. It is both a fact of astrophysics and a vessel for human longing. And perhaps that duality is inevitable. 4 stars have always been both science and story. Long before telescopes, the night sky served as a canvas of myth, a stage where gods and heroes were immortalized in constellations. The stars were guides for navigation, markers of time, symbols of fate. When modern science stripped away those myths, it did not silence the stars, it transformed their meaning. Now, they are seen not as gods, but as suns, each with worlds, each with histories. Yet they remain stories. For to imagine their worlds is to imagine ourselves among them. Proxima Centauri, in particular, sharpens this reflection. Its proximity makes it intimate. Its faintness makes it mysterious. It is not dazzling, not overwhelming, but quiet. A hidden ember suddenly revealed, suddenly charged with meaning. Humanity has given it roles it never asked for: the neighbor star, the next Earth, the stage for future voyages. It has become a mirror of human ambition and fragility, an emblem of both how far we have come and how far we have yet to go. For in truth, Proxima does not care. It burns indifferent, its flares scorching space, with or without observers. Its planets, whether barren or alive, circle it without concern for human dreams. The meaning lies not in the star itself, but in the act of looking. Proxima is significant because humanity has chosen it as significant. Its nearness makes it irresistible to the imagination. And in imagining it, people reveal themselves. This is the human meaning of the neighboring sun. It is not only about Proxima's reality, but about what humanity sees when it gazes toward it. Hope, escape, fragility, endurance. A reminder that the stars are not only to be studied, but to be interpreted, woven into the fabric of culture and identity. In the end, Proxima Centauri is both ordinary and extraordinary. Ordinary, because it is one of billions of red dwarfs, faint and unremarkable, the most common of the galaxy's children. Extraordinary, because it is near, because it is ours to imagine, because it stands as the threshold between the known and the possible. To dream of Proxima is to stand at that threshold, to see in its faint red glow not only a star, but a story, not only a fact, but a mirror. And in that mirror, humanity glimpses its own reflection, a species that cannot help but wonder, cannot help but dream, cannot help but write itself into the silence of the stars. Proxima Centauri remains what it has always been, the nearest of suns, glowing faintly in the southern dark. It is close enough for its light to reach Earth in just 4 years, yet impossibly far for human hands to touch. This paradox, so close, yet unreachable, has defined its meaning in the human story. It is a star that tempts and a star that denies. It is the symbol of distance itself, to stand beneath Earth's sky and imagine. Proxima is to feel the gulf of space in its purest form. A gulf not of empty numbers, but of time, of limitation, of fragility. Every photon that arrives tonight began its journey before words now spoken existed, before thoughts now alive had formed. The gulf is not only measured in kilometers, but in memory, in the refusal of the present ever to coincide with what is seen, and yet the gulf also carries a calling. The star whispers not with sound, but with presence, a neighbor beyond the sun, waiting at the threshold of imagination. Humanity has always answered such whispers. Oceans were crossed because a horizon existed. Mountains were climbed because they stood tall. The poles were reached, the skies were entered. The moon was touched not because these feats were easy, but because the unknown demanded it. Proxima belongs to this same lineage of longing. It is not the destination itself that matters, but the call it represents. In contemplating Proxima, humanity confronts its own fragility. Technology today cannot span the distance. Generations may pass before sails of light or ships of fusion reach outward across the void. The dream may remain unfulfilled, delayed by centuries, perhaps forever. Yet even if no journey is taken, the longing itself has value. To dream of another star is to declare that existence is not confined to one world, that thought itself is larger than circumstance. The courage to dream, despite impossibility, becomes its own achievement. For Proxima Centauri is not only a star, it is a mirror of all that remains unreachable. It embodies every unanswered question, every distant shore, every mystery that eludes comprehension. To imagine standing on Proxima b, under a crimson sky, is to imagine humanity's future written against all odds. The journey may never be taken, but the act of envisioning it defines what it means to be human. A species that refuses to accept the limits of sight, that insists on extending itself into darkness, that finds meaning not in arrival, but in striving. The paradox, then, becomes the climax. Proxima is close, but it is far. Its light arrives, but its presence is denied. It is ordinary, yet extraordinary. In its contradictions, it holds a lesson, that the universe will not give itself easily, that proximity does not mean possession, that even the nearest neighbor can remain forever out of reach. And yet, that this very resistance is what shapes longing into courage, imagination into vision, science into story. Earth remains beneath its single sun, fragile, luminous, unique. It is the cradle of thought, the sanctuary of oceans, the world where consciousness arose. Yet above it glows another sun, faint and patient, promising another horizon. Humanity stands between them, rooted in one, gazing toward the other. Forever caught in the space between home and possibility, the closing image is of a species lifting its eyes. A species fragile against cosmic scales, yet unafraid to wonder. A species that may never touch Proxima, but that has already claimed it through imagination. In that faint red light lies not only a neighboring star, but the essence of human identity, to see what is beyond reach. And to reach for it anyway, Proxima Centauri will endure for trillions of years, long after the sun has faded, long after Earth is gone. Whether humanity endures long enough to walk its worlds is uncertain, but the dream itself will endure. For in the end, it is not the arrival that defines the voyager. It is the longing, the courage to look outward, the refusal to be contained. And so, the gulf remains. And so, the calling continues.